Hi, everybody. My name is Charles Ferguson. I'm the Director of Product Management for Postgres at Microsoft. In my talk, in 25 minutes or less, I'm going to try and cover a variety of things that Microsoft is doing in Postgres, both our commitments to the open source aspects of Postgres and also what we're doing in the cloud. I hope you can join. Hi, everyone. So today, I'm pleased to talk about all the things that we're working on with respect to Postgres at Microsoft, or at least most of them, given the time that we've got. This is actually an updated talk from or an evolution, if you will, of a talk that I gave at Prague last year at PGConf EU. Now, before we get started, I'd like to spend a moment on POSET itself, because this is actually the third year hosting the virtual conference. As I'm sure you're aware, it used to be called CitusCon, but when Microsoft acquired Citus about 6 years ago. And it was quite notable at the time, I think, because Microsoft wasn't broadly recognized as a significant Postgres vendor. And then post-acquisition, of course, we continued to invest heavily into Citus, which inevitably led to the branding of CitusCon. But at the same time, we were starting to contribute more into different parts of the Postgres ecosystem as well, and of course, core Postgres itself. And so after a couple of years of running CitusCon, it became apparent to us that we needed a conference that offered a broader scope. And so last year, we decided to rename the conference to better reflect the totality of the Postgres work we're doing at Microsoft. Citus, of course, remains core to our work, but we're also contributing to other parts of the Postgres ecosystem and, of course, Postgres core database itself. So we spent a lot of time brainstorming and debating names. In the end, we decided to abbreviate what the actual intent of the Postgres conference would be. POSET stands for Postgres Open Source Ecosystem Talks, Training, and Education. Our intent is that the conference provides a platform for the entire Postgres community to talk about anything related to Postgres under a brand that is inclusive of all of Postgres. And judging by the community entrance we've had in the conference this year, we feel like we've made a really good decision here. Now, moving on to the agenda, I'm going to split this talk into two parts. The first part is about some of our recent open source work, and then I'll talk about some of the latest capabilities that we're lighting up in Azure Database for Postgres Flexible Server, which is our managed offering in Azure. First, however, I'd like to acknowledge some of the work that our organizing committee has done, and they've put together an awesome conference. Events like this don't come together overnight. And I remember when we were talking about the conference name probably 8 or so months ago now, the team really picked it up from there and has accelerated ever since until they're landing the conference here. I'd like to thank Teresa, Aaron, Ari, and Aaron, who have been working around the clock, and probably a little more around the clock than I would have preferred on a few occasions, to bring this virtual event together. I think it's come together fantastically well. You've done an amazing job, so thank you. Now, on the topic of thanks, I'd also like to thank our speaker selection team of Claire, Alicia, Danielle, and Melanie, who had probably the most difficult job, where they had to evaluate the 184 talk submissions that we received and finalize that into the 38 talks that were accepted. For those who submitted, we know it takes time and effort to put a quality submission together, and we're grateful for the effort and the interest that you've had in speaking at the conference. This is one of the hardest jobs to decline speakers who have really interesting content to share. We've already started talking about how we can expand the conference next year to make it even bigger and enable us to accept more talks from the community. And speaking of metrics, just to expand on that a little, I mentioned the 184 talk submissions. They actually came from 120 unique speakers. It's the most submissions we've ever had in the 3 years. And I'd like to think that, as I mentioned, it's in part due to the rebranding of the conference to be a little more explicit that it's open to all of Postgres. Ahead of the event, we had over 8,000 website visitors to the POSET site, and over 4,000 people have explicitly added the event. And hopefully a lot of them are joining today. We feel really good about these numbers. And at the same time, every conference sets a bar for the next year. And we're looking forward to trying to exceed that next year. Now let's switch gears to some of the things that Microsoft's contributed to open source in the past 12 months. At the top level, the best place to start is always with numbers and data, right? We're database people. In the past year, as of about the end of April, engineers at Microsoft had actually made 353 commits spanning a wide variety of features and functional areas of Postgres. And this includes work done solely by the committer, work that was co-authored by a committer at Microsoft with somebody else outside of Microsoft, all committed on behalf of another person in the community who actually authored the patch. And I think that last category is the best because it's reflected in the second box, where 27% of the commits that Microsoft engineers made were on behalf of other people. And I think that's really important because it reflects how community-led Postgres development is and how it enables Postgres to benefit from the larger engineering scale of a big population of developers while also maintaining the checks to ensure the quality remains high. Additionally, 331 commits were authored or co-authored by a contributor at Microsoft, but some may not have been committed, of course, to Microsoft engineers. So the numbers don't perfectly overlap there. These range from some of the more high-profile features, such as streaming I/O and query planner enhancements, through to smaller but no less useful improvements like performance improvements in PG upgrade, wall optimizations, and maintenance of Postgres continuous integration. Now, with respect to streaming I/O and the query planner, etc., I want to expand on these a little because the streaming I/O improvements are another forward step towards asynchronous I/O in Postgres, which has already been a multi-year effort. In Postgres 17, streaming I/O enhancements can combine page reads, which enable a single read of up to 16 pages or 128 kilobytes, rather than single pages of 8K only. Incidentally, it was during this performance testing feature that Andres actually discovered the backdoor in XZUtils, which ultimately made some headlines in a few places, as many people know. The work for streaming I/O will show up in performance for some features like sequential scans, and the analyze command will also be more performant in Postgres 17 due to the work that we've done on streaming I/O. And as I mentioned, the ultimate longer goal is asynchronous I/O, and work continues for that into Postgres 18. Now, with respect to the query planner, the changes in Postgres 17 can improve performance quite significantly for queries with the union clause, because Postgres will now be able to use pre-sorted input to eliminate duplicates, whereas it previously used things like a hashtag or another approach. There's also improvements in the redundant is not null queries as well. With respect to the performance and developer ecosystem, Microsoft has also made contributions. These include vacuum improvements that have reduced the size of the wall by up to 30%, and writing and syncing wall records may actually improve by about 15% or more in performance. There are also memory utilization improvements to sort and minor performance improvements to memory allocation. There are also performance improvements for queries involving highly partitioned tables. And as I recall, this is actually one in particular that was inspired by a real-world bottleneck that we hit with a customer that was trying to run Postgres in Azure over highly partitioned tables and was seeing performance impediments. And finally, amongst many other features that I don't have time in this session to talk about, there are performance improvements made to check the phase, in the check phase of PG upgrade, which can yield up to 2x faster completion time. And that's important because the check phase is often repetitively run as you're preparing to move things around. Outside of core Postgres, we've also contributed to Patroni. There's been a couple of version bumps on that one in the past 6 months, commonly used for HA. We've contributed to PG Bouncer, widely used for connection pooling, and PG CopyDB, which is a tool that we actually use ourselves quite extensively internally. It effectively automates moving data between servers using PG dump and PG restore. We've made a load of improvements to this, particularly for scalability, and I know there's a lot more planned in the future as well. Now, moving on a little bit more, I want to talk about what we're doing in Azure Database for Postgres Flexible Server. This is Microsoft's fully managed Postgres service in Azure, and some of the recent announcements that we've made in Build are some of the things that I'll focus on today. I also talk about one big notable roadmap feature that we're working on in the next couple of months. Now, it may actually sound a little counterintuitive, but the sheer popularity of Postgres and the breadth of use cases it addresses actually makes it non-trivial to build a cloud service that addresses all of our customers' needs. There are so many different personas and use cases. From a demand perspective, it's a great problem to have, but it also makes us think really carefully about how we can address all of our potential customers. Developers love Postgres for its extensibility, application portability between different Postgres platforms, and rich ecosystems of SDKs for building apps. And of course, I should call out the AI capabilities. A PG Vector that enables you to store, index, and query embeddings is a particular point of interest for developers right now, and we're definitely seeing that. On the other hand, Postgres popularity in the enterprise is also surging. So you've got developers and you've got the enterprise, and that's especially in the cloud. But the feature checklist for onboarding Postgres into the enterprise is incredibly different to what developers are looking for. I think this slide tries to show you that. It always starts with security, followed by high availability, disaster recovery, and the one common thing that everyone looks for is performance. So what makes this so hard to build? Well, because every engineering team has finite resources. And when the opportunity is so large to address such a diverse customer base who want to build so many different things using different parts of Postgres, we've got to think so hard through what we can build to help both ends of this customer spectrum and everybody in between to be successful in the platform. Now, to address these diverse requirements, our investments in Flexible Server and Azure over the past 12 to 18 months, have really been anchored in two distinct pillars. The first is what we call enterprise readiness, which represents basically that adoption checklist that I just mentioned. And the second, I'm sure unsurprisingly to everyone, is AI. At PGConf last year, I gave a short talk where I mentioned that Postgres had a head start on the database industry for building AI apps due to the convenient and perhaps coincidental existence of the PG vector at the time that ChatGPT took off. That statement definitely held well so far because we're seeing a lot of new apps building on AI functionality. But all of these apps still need enterprise readiness when they get to become production workloads. And that's where we think about enterprise readiness. So when I talk about enterprise readiness, I'm talking about the functionality that customers need to run production workloads. Regardless of whether you're a big enterprise, a small enterprise, all of these things are important. Sensitive data must be protected. Uptime is critical. And so this is where we've placed our investments recently. The cloud is one place that makes this so much easier. I'm probably going to date myself here a little bit, but once upon a time, I remember configuring, RAID on disk arrays, installing redundant NICs and servers, trying to eliminate every single point of failure between the CPU and the power socket in the wall. There's probably a few people who can relate to these as well. The requirements for high availability and data security have not changed. We just try to make them much easier in the cloud so that you get them out of the box. So let me expand upon these a little bit. First, we added first-class support for Microsoft Entra ID, formerly known as Azure Active Directory, which enables companies who have standardized on Entra ID to use the same login for their users when they're connecting to Postgres. And what's notable about this is Postgres in Azure is actually the only Postgres service that offers Entra ID today. With respect to network security, we actually take a two-pronged approach to this by implementing two different types of network security depending on your configuration preference. The first was virtual networks, which enables you to effectively embed or inject the Postgres service into your existing virtual networks that you had. And recently, we announced the general availability of Private Link, which provides dedicated Private Link with endpoints for connecting to your Postgres servers in Azure. And since the launch of Private Link, we've seen incredibly strong uptake from customers who are using that as their preferred secure networking configuration. For data encryption, customers can use service-managed keys provided by Microsoft, or they can use their own managed keys. We call them customer-managed keys. And they can be stored in key vaults, which are either the more traditional vanilla key vault, or even using HSM secure key vaults, which stands for hardware security modules. The service supports Azure Defender, which protects from a variety of SARs, but in particular brute force attacks. And high availability is provided using synchronous failovers between availability zones, which protect from zonal outages and automatically fail over with zero data loss. You can enable geo-recovery or failover by promoting a replica into any other region of Azure. And we recently shipped virtual endpoints with planned failovers. So now you can do this without any change to the connection string in the application and without any data loss as well. Now, performance I'll expand upon in a minute. But finally, Azure Policy is a capability that enables you to define policies on how the service can be used. And Azure Advisor, which gives you recommendations on optimal configurations for the service. It may seem pretty simple when you represent these big enterprise requirements in only 10 icons on the slide. But in reality, there's a ton of engineering effort on us that goes into delivering these capabilities. And we know it removes a lot of heavy lifting from our customers as well as they're productionizing their Postgres workloads. Now, by far and away, the most common test for any customer when they're evaluating a database is performance. Performance is a defensible measure. It's incredibly easy to measure. And it doesn't matter whether it's the first workload that you've ever run on this platform or your experienced customers and you just want to verify a particular workload before you migrate it. Performance is always one of the most critical measures. One of the things that we've done recently is introduce RDMA to be the default protocol for connectivity between compute and storage. And we also introduced the premium of SSD v2, which will bring to general availability a little later this year. And this increases your storage to 64 terabytes and your IOPS up to 80K. But when it comes to designing the database schema itself, this is where the art is. There are no free lunches in defining database schemas. There are always trade-offs. One of the closest things I have ever found to building databases, the silver bullet, if you will, is indexing. But indexes are hard to maintain, particularly at scale. At the Build conference a few weeks ago, we announced the public preview of automatic index recommendations. And this is an incredibly powerful feature because it profiles the totality of your Postgres workload running in Flexible Server on Azure and advises on the index to create or drop. The index recommender can either create new indexes or delete existing ones, whether redundant or used, as you can see on the screen here. Because the feature analyzes the workload at the actual database layer itself, it doesn't matter whether you're being invoked from a function or the code's written to a function, it's hard coded into the application code, or dynamically built by the application at runtime. Automatic query tuning analyzes a production scale. And whether you have hundreds or thousands of tables, potentially tens of thousands of different queries submitted to the database every day, there's a huge productivity gain for developers or administrators who no longer need to manually profile or debug workloads to determine missing indexes. This feature was jointly developed with Microsoft Research. We're really excited to put this feature directly into the service and into the hands of our customers so that they can start to turn it on, see how they can potentially optimize their workload, and get immediate out-of-the-box gains from using Postgres in Azure. Of course, I couldn't talk about Postgres in Azure without talking about AI. AI has had an absolutely profound effect on the technology landscape over the past 18 months, and Postgres, the database, has found itself right in the middle of it, with this huge head start over other database platforms, due almost entirely to the pgvector extension that enables Postgres to natively store, index, and query embeddings, as I mentioned earlier in the talk. This feature enables you to run a similarity search using embeddings, which could be used as a basic search result, using where you calculate the distance between embeddings, or using as contextual input into a language model in a more RAG-based application pattern. Last year at Ignite, we announced the Azure AI extension in Postgres, which enables customers to invoke models out of the Azure OpenAI service. And this is powerful because it gives you the choice of models that you want to run for your workload. And we're already seeing customers experimenting with different types of embeddings depending on the nature of their data. It also supports integrations with the Azure AI language service for scenarios such as sentiment and summarization. It integrates with Azure AI Translator for translating text, and Azure Machine Learning, where you can bring your own ML models, generate predictions using the data that you've got in Postgres. And in May, just gone by, we announced the general availability of the Azure AI extension. And so now it's available for you to use in production with the guarantees that come with being a generally available component. However, sometimes performance is the most important element. Like I said, every database is a drag race. And so your applications that you build need to have the best performance they can, and that includes creating or modifying embeddings. So Build in May, we introduced a new way of creating embeddings using Postgres in Azure. We introduced the new extension called Azure Local AI, which leverages Microsoft's open source E5 embedding models, which are available on Hugging Face and other places, running locally in the Postgres service itself to generate embeddings in single-digit millisecond latency, as opposed to the remote invocation that we used previously. You can see in this video that the remote AI embeddings are running on the left, where it's making a call to service. That's what we shipped about 8 months ago. And on the right, the local model that we shipped in May, where the model's running in the engine. On the left, we're going to run about 600 times. On the right, we're running 800 times, as you can see in the commands. I don't know why we did different numbers, but immediately you can see the performance difference. On the left-hand side, we sustain around about 15 to 20 transactions per second, and it's still running, although it just finished. The right-hand side finished in a fraction over 3 seconds, with an average latency of about 4.1 milliseconds. When you get down to such low millisecond times, you can start to really confidently put these embedding creations in your OLTP application and know that it's going to sustain the throughput that you need. Now, before I wrap up, I'd like to share one other significant feature that we're working on right now and we're planning to ship soon. DiskANN is another amazing innovation coming out of Microsoft Research that provides state-of-the-art vector indexing. In May, we announced support in our NoSQL platform, and we're working right now to bring the DiskANN vector indexing into Azure Database for Postgres Flexible Server very soon. So watch this space. Now, one of the most interesting characteristics about DiskANN is that it maintains its recall quality as data is added or modified to data. Basically, it maintains the quality of search results when you're running those similarity searches. What you can see in this chart is that the recall in HNSW, which is the current effectively state-of-the-art in PG Vector, declines as the index is changed, which means that embeddings are added or modified. DiskANN retains that recall, which means your queries continue to return the most relevant information for your AI apps, which is really one of the most important considerations for building similarity search, but all for returning those results to your RAG-based applications. So that pretty much concludes what I had time for today. As you can see, Microsoft continues to be very heavily invested in Postgres, both in open source, where we made a couple of headlines earlier this year, as I mentioned, with respect to that backdoor. Also, the surrounding ecosystem of applications that I talked about, PG Bouncer and Patroni and PG CopyDB. There's a great blog that Claire Giordano and my team authored a couple of months ago now. Perhaps maybe we can put the link on the screen. I don't know about that. That gives you an exhaustive view of everything that we're doing in Postgres and Microsoft. We're also really active in a lot of the open source community events. I know we've got big events coming up in New York and I think in Greece this year. Microsoft should be out in full force in those as well. I look forward to seeing hopefully a lot of you there as well. We also continue to invest heavily in the cloud. We want to continue to make our cloud service more performant, more feature-rich, ideal for the enterprises who want to adopt it with that really high security and compliance bar, and a great place for developers who want to build those new apps and leverage all of the amazing AI capabilities that are lighting up in Azure. I appreciate your time today. Thank you again very much to all of our organizers and our speaker selection team. I think you've done a phenomenal job. As I mentioned, the conference has come together great. Thank you everyone else for joining. I think there's some great talks here. Please enjoy the rest of the conference. Thank you.